The last thing I want to talk about is removing missing values or NA values from an object. This is a very common operation in data analysis because most realistic data have lots of missing values. And so the way you can do this for either a vector or a matrix or a data frame is you want to create a logical vector which tells you where the NAs are, and so that you can remove them by subsetting. So here I've got a vector x. This is a very simple example, which has the numbers 1, 2, and 4, and 5. But then there are missing elements NA in the third position and in the fifth position. So what I want to do is I want to get a vector back that's just 1, 2, 4, 5, the non-missing values, and I want to strip out the missing values so I can maybe do some computation. So first thing I do is I use the is.na function to go through the vector and tell me which elements are NA. And I create a new vector which I call bad here. So bad is going to be a logical vector which is true if the element is missing and false if it's not missing. So even though I haven't printed it here, the bad vector is going to be a logical vector that has false, false, true, false, true, false, right? Because the third and the fifth elements are missing. So now that tells me which ones are missing, but actually I don't want the ones that are missing. I want the ones that are non-missing. So I need to take the kind of the opposite of bad, which I can use with the bang operator or exclamation point. So now I take x single bracket bang bad, and that gives me the good elements, which are 1, 2, 4, and 5. So what if there are multiple vectors or multiple objects, and you want to take, and each one has kind of missing values in slightly different places, and you want to take the subset of all the objects that have no missing values, right? So here I created a vector called x, which is 1, 2, 4, and 5, and missing values scattered about, and then y is a character vector with also some missing values in it. So I can use the complete cases function on both vectors, which will give me a vector that tells me which of the two different vectors, which positions are there that have both elements non-missing. So you can see the first two are both non-missing. I got 1, 2 in the first one and A, B in the second one. The third one's missing. The fourth one is non-missing. The fifth one is missing, and the sixth one is non-missing. So for both vectors x and y, I want the first, the second, the fourth, and the sixth elements. So now when I subset x, I get the good elements of that, and when I subset y, I also get the good elements of that. So that's how I can look at multiple objects and kind of subset all the missing values out to get the good elements. You can also remove. You can also use complete cases to remove missing values from data frames. So here I've got a simple data frame where I'm showing the first 6 rows. As you can see, there are 6 columns to this data frame, so there's 6 variables. And there's some missing values in the ozone variable, and there's some missing values in the solar.r variable. And so all I want is the rows of the data frame where all the values are non-missing, right? So in this simple example, the rows that I want are rows 1 through 4. So I can use complete cases on the air quality data frame, and I create a logical vector that I call good here. So the logical vector here tells me which rows are complete. And then when I subset out the air quality matrix, and I take out the first couple rows, you can see that none of the rows have any missing values in them. So that's subsetting out missing values. And complete cases is a very handy function, which is when you have multiple sets of vectors or large data frames where you want to subset out all the missing values.